Hello, students. Let me go through the procedure with you. So first of all, I have to go to the procedure. It starts from here. So go to this link. So you will select the link, and then open the link. Paste it here. Okay. Then we go to ideal gas law. Let me see what the instruction says. Under hold constant. Okay, so they kind of changed the simulation a little bit. So we are going to go to this one. This is the experiment actually. So this is the experiment. And then let's see. Next, under hold constant, select volume. So we are going to select volume and set the temperature scale to degrees Celsius and add the 310 particles. All right, so let me see. All right, so volume has to be held constant. We want to have a constant volume, no changes in volume. And the number of particles, this one has to be 310. So the light or heavy. So 310 light particles. 310 light particles. 310. Oh, it's too much. So let's this one. 310. Okay, so we have 310. And the temperature has to be in degrees Celsius. All right, so that's the settings. Your volume has to be constant. You add 310 light particles, and the temperature has to be in degrees Celsius here, not Kelvins, but degrees Celsius. All right, and then we are going to add heat to start from, well, we tamper with the temperature, so we start from minus 90 degrees Celsius, and then by following this table, so minus 90, and then we put our temperature in Kelvins. I mean, we convert this, we can just convert. So I'll go and right now I see it's 35, so I have to remove the heat until I go to minus 90 degrees. So I'm trying to cool the gas. As I'm cooling the gas, I see pressure is decreasing here. Oh, that's too much. Okay, so somewhere there. Oh no. So keep trying until you get to 93 or 90. Okay, I think it's 90 or 93. Yeah, 90. Yeah, okay. Then you're going to convert to Kelvins. I know you can just go here and change the temperature to Kelvins, but I want you to learn to use the formula. I don't know if I have given you here. The formula is not here, but I want you to search on internet how to convert degrees Celsius to Kelvins. So search on internet, find the appropriate formula to convert minus 90 degrees to Kelvins. Record the pressure here. So let's go to the simulation. The pressure is 21, 22, 21, 22. So looks like an average of 22. So you can put 22 ATM. ATM is our unit of pressure. So put 22 here. All right. So you go ahead, do the same for this one, and then you get your pressure and go to minus 30, go to pressure all the way here. until you complete this table. All right, so, and then you're going to enter the temperature values in column A of Excel. So you go to Excel, this is Excel, this is column A. So you put your numbers there. So I can just copy and paste here, show you. I can just copy these numbers, and I'll go to my, yeah, so here, so these are my numbers here. Then I'll copy the pressure values here. So I had 22. Then you can go ahead and I'll do this quickly, and then I think you can do a good job. So let's move on to 60. 60. Well, go to 60. Okay. I might not get it close, but you guys can do a good job. So right now it's 20 what? 25.5 maybe. 25.5. So put here 25.5. And let's try minus 30. Minus 30. Go there, add heat, minus 30. Where's minus 30? Minus 30, somewhere there. Well, I'll stop there. I try, oh, there. So 29 is fluctuating, but on average is 29. I'll put my 29 here. Okay, and then what about temperature of 0? So let's make it 0. No, go down. Well, kind of. Okay, so that's about 32. So I'll get 32 here. 32. And then I go to 30. 30 degrees. So 30 degrees. 30. Yeah, there. So pressure now is what? Pressure is 30. 30 what? That's 36. So I'll get 36. Put it here. Then 60. So go back and try to add more heat to 60. Keep on doing this to 60. Well, that's about what? Close to mostly 40. So maybe 39.5 if you want to be more accurate. 39.5. It's up to you. And then 90. Let's go to 90 degrees. It's very hot. So 90 degrees, close to the boiling point of water. 90 degrees is a lot of heat. Yeah, there. So you wait a little bit until you stabilize. You see that looks like 43.5. Looks like 43.5. Let me see again. Yeah, 43.5. That's what I'm seeing there, 43.5. So 43.5. All right, so that's your data. And go back to this. So column A, temperature in column A and pressure in column B. And then we are going to plot our graph. Okay, so let's plot our graph following these instructions. So you select all the data, then click insert. Then you go here where you have a scatter plot. So this is a scatter plot. Insert scatter, then the first one, click the first one. First one. Then you can right click, okay, right click like this. You add a trend line. Then, you know, your graph has to go all the way here. It has to cut the x-axis. So you are going to extend it here by putting a 200 here at 200. All right, make it linear. And you might want to display equation on the chart, make it straight. All right. So when you do this, you have your graph line, straight line, and it cuts the x-axis at this point. So this point will be your lowest temperature possible. So this is the point you have lowest temperature possible. Let me see if I can point that place. I can point it here, right here. It's between minus 300 and minus 250. Somewhere there, that's the lowest temperature. It looks like minus 275 degrees Celsius, but you can do a good job to find the exact number, either by carefully looking at this or by playing around with this equation. Okay, so you can do that to find the temperature when the pressure is 0. So the temperature when there is no pressure, this temperature when there is no pressure is called the absolute 0. So that is the point when pressure is 0. So pressure is 0. That point is called the absolute 0 temperature. Okay, so that's the lowest temperature possible. The lowest temperature possible. Okay, so that's how you find this. You can also plot these numbers on a graph line manually. So without using the computer, you can have your graph paper. Maybe you bought your graph paper from the store. You can use the graph paper to actually plot the pressure on the y-axis and the temperature on the x-axis. Okay, so you can do that. But let me show you how to do the labels axis. So let's put axis titles. Okay, so you can go ahead here and it says this is a pressure in ATM. So you can just say pressure in ATM. And this one is what? Temperature. Temperature, and this one is in degrees Celsius. And the title you can just say pressure versus temperature graph of ideal gas. Okay, of gas or ideal gas. Okay, that's your graph. Then you can actually use this to share with me. Just copy here. You can copy the table and put it in a Word document. It's up to you. You create a Word document and paste it there. So you can just paste it like that. Okay, and then you can go ahead and complete the rest of the lab. Let me see what else we have here. Oh, there is also a video here of the actual experiment, but it only has 2 points. Here we have so many points, but here you only have 2 points. You are going to record the temperature of the cold water and then boiling water. So we are going to put a gas in, we'll follow this link. You watch the video, and the gas is in a container, in a container, and then you will put the container in cold water, and the container is connected to a pressure gauge. There's a pressure gauge there. So you are going to find the cold temperature and its pressure. Boiling temperature, watch the video and record the pressure. Then here you need to do it manually because Excel won't allow you to plot using 2 points only. Okay, so use these 2 points to manually plot your graph. You can go back to the first video if you want to watch how to plot a graph manually. But my advice is to make sure that you extend the graph line. It has to look like this. Okay, so let me see if I can draw something, shapes. No. Drawing, design, set. If I wanted to see if I can draw something, draw a shape. No. So I don't have it here where I can actually write on here. Where is it? Anyway, I can go here and share the screen, stop screen share, and probably share the whiteboard. I can share the whiteboard. So what I'm saying is that you have to draw a line, another line here. It has to be straight, not like mine. It has to be straight. So draw a line. So make a nice line here. It has to extend all the way there. Okay, and then put numbers. So I want you to put numbers like -50, -100, -150, -200, -250, -300. Yeah. So minus 50 here, -100. So this you do it manually. -200. Oh, 150 here. So 150 here, 150 here, and -200 here. -200, -250 here. And -300. You need to do that. All right, so this is minus 150. -150. Okay. All right, so 50, 100 like that, and then do the same here. You get 50 and maybe 100 here. All right. All right, so you should get, after you plot the 2 points, I'm talking about this, remember, I'm talking about this. You only have 2 points for the cold water and boiling water, temperature and pressure, okay? You only have 2 points. So you're going to, let's go back. Where are we? Oh, we're sharing the screen. Okay. I'm sharing the screen. Oh, here. So if you do everything nicely, you will get a line, the 2 points. If you extend the 2 points, you will see the line. I can't tell exactly how it will go like, but it will pass through somewhere here to show that that's absolute 0. So that will be your line, and you might have the cold water somewhere here, maybe warm water, boiling water somewhere here. Then you connect all this line, and where the line crosses the x-axis, that's where the absolute 0 value is. Yep, remember these are degrees Celsius, and this is the, according to the video, this is the pressure. That's PSI, pounds per square inch. See, they're using pounds per square inch. Okay, so that's pressure on this axis and the temperature on this axis. So temperature in degrees Celsius. All right, so temperature in degrees Celsius. All right, so this is the kind of graph you will end up with. I will need the labels and title here, title of the graph, okay? Then you say, according to this experiment, then my absolute zero is here. So you can now say it is here. That's where the absolute value is, between this and this number. All right. You'll see that in the video, they're using a pressure gauge. It looks like this one. They're using a pressure gauge. Let me see, draw. It's just, there is a gauge here with an arrow and it's connected to a giant container, spherical container. And there's a valve here to allow air to go inside. Once the air goes inside, you close the valve. You close the valve so air goes through here, and you can close the valve here after allowing air to go inside. Once you allow air to be inside here, you put this in cold water. So you put this in cold water, okay, in cold water. Then you see the pressure will be changing. So you see the arrow changing here because the cold water is at a low temperature, so it will decrease the pressure here. And you can also put this in warm water, maybe it's warm water, and then you do the same thing. Try to dip your thing in the in warm water or maybe boiling water. Then you see the pressure will be high here, high pressure. Okay, so that's all about the video you're going to watch here. Anyway, that's it. I hope you will be successful in this lab. I wish you all the best. If anything, let me know. I'll answer your questions. Thank you so much.